OK, here is a concrete example of a denial of service attack. So far, we've been kind of vague. We've been talking about it at a high level. So let's give you one concrete example of an attack that someone might do using one of the protocols that we've already seen. So this type of attack targets TCP. Remember that with TCP, TCP is happening between a client and a server, and both sides of the TCP connection have to keep track of some state, some memory. So think about what the server has to keep track of. They have to remember their own initial sequence number. They have to remember what the current sequence number is as they send more packets. They have to remember what packets have been acknowledged so that they don't send them again. They have to remember what packets have been sent out of order because they have to keep those around until the missing packets arrive. So basically what we're saying is that this server has to keep track of some things in its memory when it's running a TCP connection. And for every single TCP connection you create, you have to keep track of memory for that connection. So if I start 10 different TCP connections, then I have 10 different sequence numbers to keep track of, 10 different ACK numbers to keep track of, 10 sets of out-of-order packets to keep around until the in-order packets arrive. So there's a bunch of stuff that we have to keep track of. And memory is limited. A server might not have infinite memory to keep track of 1,000 or 10,000 TCP requests. So right away, we can see that one way to do denial of service is to establish a lot of connections with a server. And for every connection that you make, the server has to consume some memory to keep track of some numbers and things like that. And if you start, say, 10,000 connections with the server might run out of memory and not have enough memory to start TCP connections with legitimate users. So that's one possible attack on TCP, overwhelm memory by starting a lot of TCP connections. So far, what we've described is a possible denial of service attack, but it's pretty symmetric. If you're the attacker and you want to send or overwhelm a server, then you need to create 10,000 connections so that the server also creates 10,000 connections and gets overwhelmed. The attacker doesn't seem to have an advantage here. The attacker would also have to create memory for 10,000 connections in order to overwhelm the server. However, if we use a trick called SYN flooding, we can execute the same attack to overwhelm the server, but we can give the attacker a big asymmetry advantage where the attacker can use minimal memory of their own, but still cause the server to crash and use all of its memory. The key to the SYN flooding attack is to notice that the TCP handshake starts with the client or the attacker. And as soon as the attacker sends this first SYN packet, the server has to open up state. They have to start remembering this number x. They have to allocate memory using something like malloc in C to have enough space for out-of-order packets or ACK numbers or anything else. So in other words, the instant the attacker sends the SYN packet, the server already has to open up a lot of memory. And at this point, the server will send a SYN ACK and wait some time for an ACK. But the attacker doesn't really have to finish the handshake themselves and open up their own memory because the attacker isn't trying to start a real connection. By the time the attacker sends the SYN packet, the server has already malloced some space in memory. So the attacker's job is done for this connection. And the attacker doesn't have to go through the trouble of remembering a sequence number of their own and sending this ACK packet to finish the handshake. They can just leave the handshake here, and the server has already suffered the damage of creating a new connection. So the attack, in just a few words, is to have the attacker send tons of SYN packets. Don't bother with the ACK packet at the end of the handshake. Don't bother with more data packets. Just send nonstop SYN packets without allocating any of your own memory as the attacker. And every time the server gets a SYN packet, it thinks that a new connection is starting. So it mallocs some data for that connection. And if the attacker sends 10,000 SYN packets, the server has to call malloc 10,000 times, and they might run out of memory for legitimate users. And through this whole attack, the attacker doesn't have to keep track of anything. They don't have to remember their own sequence numbers. They can just generate random sequence numbers, send the SYN packet, and forget about it. However, the attacker, or the server, is forced to remember that sequence number because the server might expect that an ACK packet is coming later and more data is coming. So the server has to call malloc ahead of time. That's the attack. We saw that the server can malloc data on every TCP connection, and we can overwhelm that by starting lots of connections. Then we introduced the idea of SYN flooding and ignoring this final packet. The attacker doesn't send it at all, and that's what introduces the asymmetry that makes this possible for an attacker.